Okay, guys, today actually we're again continue what we started last time. Who can remind me what we studied yesterday? Okay, what we studied yesterday, guys? Yes, Hannah Hamdi.
We studied about the single replacement and double replacement and the synthesis.
So, synthesis, single replacement, double replacement, decomposition. What we call all of these? Yes, Reem?
Types of chemical reaction.
Types of chemical reaction. Good. Okay. So as we said yesterday, we have hundreds or maybe thousands, okay, or more of chemical reactions that could happen in our daily life, whatever in the practical life or even in lab or whatever. These reactions, whatever this huge number, could be categorized into certain patterns or certain manner in which the reaction happen, and we call them the types of chemical reaction. And we said generally there are five types of chemical reactions, or as we said yesterday, just five types, four types of chemical reaction, but actually there are five. We're going to study five types of chemical reaction. So yesterday we watched a video that explained how these different four types of chemical reaction, synthesis, decomposition, single replacement, and double replacement. So let's remember, guys, here. Okay, first let's check that you remember what we studied yesterday. So we're gonna write a chemical equation, and then in chat box you are gonna tell me what is the kind of that reaction. So here, for example, when we say, so who can tell me what the kind of this chemical reaction, right in chat box, guys? Everyone, hurry up.
Let's have a chat
So
box.
the chat box, right? Chat, okay. Click on the chat,
Yes.
okay, down. You're gonna find. So yes. So Kinsey, Reem, they answered. The others, please, yes. Hannah, good. Okay, good. Adam, brilliant, brilliant. Okay, so guys, most of you or all of you, you agree that is synthesis reaction. Okay, so anyone can tell me why it's synthesis reaction, guys? Okay, if you said why it's synthesis, yes, Kinsey. How do you know that is a synthesis reaction?
Because one element or more substance that combine and form a compound.
Okay, good. We have two substances. Okay, these two substances could be elements of compound. Here we find that there are two reactants. They combine and build up one product. So of course it's a synthesis reaction. Yes, is it clear?
Yes.
Yep. Okay. So here let's find. Okay, let's take another example. Let's see. For example, with what about the kind of the following reaction which I'm gonna write? For example, let's say so who can tell me what the kind of this reaction, guys? So Kinsey, Hannah Hamdi, Hannah Dugam, okay. Right, guys. All of you are right. Brilliant. Okay. So all of you or most of you, as you said, you agree that this reaction is a decomposition reaction. Yes. So this one is synthesis, okay, and that one is decomposition reaction. So why that is a decomposition reaction? Who can tell me why we find this is decomposition reaction? Yes, Rashwan. Yes, Rashwan. Rashwan, can
Sorry,
you? Yeah.
I thought I was muted.
So why it's a decomposition reaction?
Because the composition reaction, um in which like low compounds break into two
Yeah,
or more
good.
simpler substances.
Good. So here we have one compound that break down into two compounds, or as we can see, one reactant break down into two products. So of course that is a decomposition reaction. Brilliant, guys. So like this, we could follow the manner, or we could predict what the type of the chemical reaction from the chemical equation. Let's pass to the, okay, let's try here. So let's find, for example, mm, That's I, guys. Okay. So what the kind of this chemical reaction, guys? What do you think? Write in chat box also. So single replacement, single replacement. So good, guys. Good. Hana Hamdi, Kenzi, Nano, Durgam. Okay, Hana Durgam. Brilliant. Jana. Okay. So tell me, guys, what, why? Okay, or how do you know that is a single replacement? Yasreen?
Because one element replaces another element.
Yeah,
Oh,
what here you will find that Li replaces Cl, it kicks it
yeah.
out and take its place, it combined with chlorine. Okay, so that means Li substitute calcium and forming lithium chloride. Yes?
Yes.
Yeah, so we're good about this. My question, this reaction is already done. Okay, so that means lithium could replace calcium. Okay, so then we said, let's see here. For example, if I said Cu plus CaCl2. Could copper replace calcium here, guys?
No.
No or yes? How do you know? So actually, no, no reaction will happen, okay? So copper cannot replace calcium. Cu cannot replace, okay, Ca. So if copper cannot replace the calcium here, okay, but lithium could replace the calcium. So it means there are some elements could replace other while some elements cannot. Yes?
Yes.
Mister, how bad do we know
Yes.
the element?
Yeah, that's suppose that's your okay kind of task yesterday. Okay, we asked you to find the answer. How could we know that some substances they could okay replace others or not? How could we know? Okay, anyone could figure? Anyone could predict? Did you find the answer? Suppose you already keep searching for that answer yesterday. Anyone remember, guys? Or anyone find it? Yes, Nano.
Mr. هو I think if
Yeah.
يعني there are some minerals that are the same characteristics as others. If it's the same
So
characteristics and can react,
so
it can be
actually
replaced.
lithium and the calcium, they are metals. Copper and calcium also they are metals. Okay, so why lithium could replace calcium while copper cannot replace calcium, although all of them are metals. So that means somehow they have the same characteristics. So actually, it doesn't depend on characteristics. Okay, so
Okay.
yeah, let's see. Reem,
هو I'm not sure برضه بس بس إيه
yeah.
هو because the element replacing it المفروض تبقى يعني تبقى more reactive.
The one who replaced or the one who replaced?
يعني لا the element the element will replace its place يعني.
Yeah, the element, okay, the most reactive element replace the less reactive one.
ال-
So that means lithium is more reactive than calcium, so it could replace it. While copper is not reactive, calcium more reactive than copper, which means copper cannot kick the calcium out, cannot take its place. Okay? So that means it depends on the element reactivity. So how could we know which element is more reactive than the other? I think that the question which you asked, yes? Yes,
yeah.
guys? Okay.
Yes.
So here I'm gonna answer you, okay? Just wait with me. So actually, scientists they arrange elements regarding to their okay regarding to their reactivity, and they make a kind of a list. Okay, we call it the chemical activity series. Okay, so in chemical activity series, it's just a descending order that represent okay the elements. So let's see here, guys, together and start to explain. Just a minute, sure. Okay, could you see this sheet, guys?
Yes.
Okay,
Yes.
so actually that will be fine. You are gonna find it uploaded in your SMS and the folder of summaries, okay, and PPT. So you're gonna find this found. So you're supposed to know it and memorize it, okay? So here, guys, single replacement reaction. We said in single replacement, the reactive metal can replace the less reactive metal in a compound. So for example, here we find sodium is more reactive than zinc, so it could replace the zinc, take its place and forming sodium chloride, and this zinc is kicked out. Okay, so here like this, we know that because sodium is more reactive than zinc. While, for example, copper cannot replace the iron. Okay, so like that, in that case, okay, this no reaction will happen. Why? Because copper is less reactive than iron. So how could we know, guys? Let's see together. This represent, okay, or in that case, we're gonna find this chemical activity series. It already arranged the elements in descending order regarding to the reactivity, which means that potassium, okay, or actually lithium, okay, up lithium is more reactive than potassium also, okay. So we can add here more, okay, lithium, okay, Li, okay. So lithium, which is Li, it's more reactive, but just that is enough, okay, no problem here. So we find that potassium, sodium, calcium, magnesium, aluminum, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold, okay. So as we move down, the reactivity decreases, which means, okay, the first element in the chemical activity series of the first metal, potassium, could replace any one beneath it, okay. While, okay, iron, for example, can replace tin, can replace lead, hydrogen, copper, but it cannot replace zinc or aluminum. Is it clear like this, guys?
Yes,
Yeah.
yes.
So like this, it means, okay, each element in the list could replace what beneath it, but cannot replace what above it, because what above it is more reactive than it. So it cannot replace. You get the idea? Is it clear, guys?
Yes. Yes.
Okay,
Yes.
so that's here regarding to the chemical activity series, or that's what means by the chemical activity series. So if you could observe here, guys, you're gonna find in the chemical activity series, it's just divided into two parts, yes? One part above hydrogen and one part below the hydrogen, yes?
Yes.
Yeah. So actually, why we put hydrogen here, although hydrogen is not a metal. So hydrogen is a gas. So that's non-metal. Why we put a non-metal in the list of metals? Anyone have an idea, or do you think why? Do you know? Let's try to think. Let's find why we put hydrogen here, although hydrogen is not a metal, and we just put it in a chemical activity series of metals. Okay. Yes, Maya.
because it reacts يعني
Reacts
as a metal.
as a metal. Actually, we find that, okay, hydrogen in some chemical reaction, in some, okay, in most compounds, hydrogen represent the positive side of the compound. What does it mean? We can understand this. Let's see. Anyone? Okay, let's remember some chemical compounds, like for example NaCl. That's sodium chloride. Yes or no? Okay.
Yes.
So let's take another example. For example, FeO, iron oxide, the rust. Okay, let's take another example. For example, Mg, for example, let's say MgPr2. Okay, so here all these are chemical compounds: sodium chloride, iron oxide, magnesium bromide. So this chemical, whatever, we're gonna find that always any compound could be divided into two half. Okay, two parts. Okay, you get this? The first part always is the positive part of the compound that represent, okay, the atom, which somehow could give electrons, okay, or somehow they could make the electrons move a little farther from it rather than the other atom. Okay, you get the idea?
Yes.
So whatever, the first part of any chemical compound is the positive part, okay, while the other part is the negative part. So always the positive part, they are metals, as you can see: sodium, iron, magnesium, blah blah. So also we find that once hydrogen combined with other non-metals like HCl, for example, okay, like HSO4, so H2SO4. Okay, so we find that hydrogen also represents the positive part. You get an idea?
Yes.
So it behaves somehow like metals in some compounds. Okay, so that means in that case it could be replaced by metals. That's what we put it in that list. Is it clear, guys? Yes, Fadi, do you want to ask something?
Yes.
Yes, start.
Miss, I don't understand the hydrogen part.
Okay, okay, let's think again. We said in single replacement, you can see in the screen, the reactive metal can replace the less reactive one. So scientists already make a kind of list, we call it chemical activity series, in which they arrange the elements or the metals in the ascending order regarding to their reactivity. So the most reactive metal is going to be at the top, and the least reactive metal will be at the bottom. So any metal in the top, they could replace what beneath it, but no metal can replace what above it. We agree about this, Fadia? Is it clear?
Yes, yes.
Yes. But here in that list, we could find that there is hydrogen in the middle, but hydrogen actually is not a metal. So why we put hydrogen, which is non-metal, in a list of metals? We said because hydrogen in some chemical compounds, it behave like metals, Fadia, okay? What does it mean? I give you different examples here. Sodium chloride, iron oxide, magnesium bromide. We find that always we start by the metal, which represent the positive part of the compound. Okay?
Mister, I have a question.
Just a minute now. Okay, Fadia, are you with me? Fadia, I can't hear you.
Yes, yes.
So look with me, Fadia. I'm gonna write something and tell me here. For example, CuI2. Okay, could you tell me, Fadia, where is the positive part?
Cu اللي هي copper.
Yeah, good. Cu, that's copper, that's the positive part, while I2 is the negative one. Yes? Okay? Fadia, I think there is a problem in your mic. Is it okay?
Yes.
Okay.
Mr.
I
Can
think you have a problem in the internet, so if you could write on chat, okay, that would be
Mr.
fair. Yes, I hear you, Fadia, right now. So you agree now that Cu is the positive part, I2 is the negative one. So what do you think? I'm gonna write another one and tell me where is the positive part, okay? So where is the positive part, Fadia?
HB.
No, that's HBr. Any symbol of any chemical compound.
BR.
So yeah, so that the positive part is H while the negative part is Br. Yes.
Yeah.
So in that case, you observe that the hydrogen it acts like the copper.
Metal.
Yeah, so it's act like or behave like metal in some chemical compounds. So that means in a chemical reaction, okay, they could be replaced by another metal. Okay.
Okay.
Okay. Yes, Nan, what is your question?
Mister, يعني metals react with less with more reacted metals.
Yes.
The gases and liquids بقى وكده.
No.
Do they برضه react?
Wait.
Do they have a rule ولا لا؟
Wait. You messed that up, okay? Gases, liquids, it doesn't mean, okay, that a certain kind of, or it doesn't mean it's a metal or non-metal. Gas, liquid, they are, okay, states. For example, I said to you NaCl, okay, that is sodium chloride. I could dissolve it in water, and in that case, it could be solution, so it's liquid, but it's still NaCl. You got an idea?
Mister, بس non-metal و non-metal.
Yes, you talk about non-metals. So the question must be modified. We don't ask about gases or liquids. We ask about non-metals, okay?
Yes.
Yep. So here like this, okay, the basic same thing that we depend on first on metals. So anyone cannot understand the part related to the metals, guys? Clear, okay? So like this, okay, we could find that here they represent, okay, the idea, or like this, we could find regarding to the chemical activity series, the most reactive metal could replace the less reactive one. So maybe in the exam, I'm gonna give you a chemical reaction and ask you this chemical reaction can work or cannot. So you're supposed to decide regarding to the chemical activity series of the element is more reactive, like here sodium is more reactive than zinc, so it will replace it. If not, so it will not replace it. So that's regarding to metals, as far as Nano said. So now we ask about, yes.
Mr. why can't Mr. يعني replace the least reactive to the most reactive يعني for example mercury we can't replace it with potassium.
Mercury cannot replace potassium.
Yes.
Because mercury is less reactive. What are you asking? Why less reactive cannot replace the most reactive?
Yes.
Because once we call about the word reactivity represent the ability of the atom to form a stronger bond, which means potassium already once it bonded, for example, if potassium is bonded with chlorine, forming potassium chloride, okay? So that's here KCl. The bond between K and Cl is too strong bond, while mercury cannot form a bond like this. It will be weaker, so of course it cannot replace it. You get the idea?
Okay, yes.
Yeah, so
Thanks.
that's the point. Okay, the word reactivity means how much this element able to form a bond. Okay, so of course the most reactive, it able to form more stable, more strong bond, so it cannot be replaced by weaker one. Okay, so any other question regarding to this part, guys, or is it clear?
No,
Is it
thank
clear,
you.
guys?
Yes.
Yep. So back to the question of Nano, she asks about non-metal. Actually, non-metals also, they have kind of a rule, but actually the rule of the non-metals, okay, depend on their position in the periodic table. So we could find that the elements in the same column in the periodic table, okay, as we move up to down, that their reactivity decreases. So we're gonna get example of one column of the periodic table, which we call the halogens or the most reactive non-metals. So we find that fluorine more reactive than chlorine, chlorine more reactive than bromine, and so on. All these metals or these non-metals, they belong to the same column in the periodic table, belong to the same group. Do you remember the periodic table? We said it's divided into groups and periods. Do you remember this, guys? We studied last year.
Yes, yes.
Yeah. So in the same group of non-metals, the metal with the same group of non-metals, the element which found at the top is more reactive than what beneath it. Okay. Is it clear?
Yes, yeah, Mr.
Yeah. So like this, in that group, fluorine more reactive than chlorine and bromine and so on. So they could replace it. So here, for example, fluorine, that is a non-metal. So suppose it's gonna replace the non-metal part. So no one replace it with sodium because sodium is metal. Why, for instance, so the non-metal replace the non-metal. So fluorine could replace chlorine. Okay, you get the idea?
Yes, yeah.
While iodine cannot replace bromine. Okay, because iodine is less reactive than bromine. Is it clear like this now, guys?
Yes.
Yep. So like this, okay, we know what is, okay. So Reem, Fadia, Nano, do you have any question or just still raising your hands?
No, it's from the previous question.
No,
Okay.
yeah, Mr.
So like this, guys, okay, let's back to our presentation. So we know like this, what is the synthesis reaction and the decomposition, single replacement, and we understood now, okay, single replacement based on the reactivity of the element. So the most reactive element could replace the less reactive one. And of course, metals replace metals, non-metals replace non-metals. So no one use a metal to replace non-metal. It cannot happen, okay? Is it clear, guys?
Yes.
Yep. Okay. So like this, okay. Okay. Brilliant. So like this, guys, we know what are, okay, the three different types of the chemical reaction. We still have a fourth type we're going to talk about, which is a double replacement reaction. So in double replacement reaction, we find that we have two compounds, okay? Each compound, of course, is made of metal and non-metal, or positive part and negative part. And also this is made of positive part and negative part. So they are gonna switch places, okay? Like for example here, NaCl, Na is the positive part, Cl is the negative one, plus AgNO3, Ag silver is the positive part, NO3 nitrate is the negative part. So they switch places. Is it clear?
Yes.
So my question here, guys, in that case, should we also depend on the chemical activity series?
Yes.
No.
Why?
Why? Because of course, one of these two elements, as they are different, suppose one of them will be reactive more than the other. Yes? because they are not the same. So of course they don't have the same reactivity. So of course one of them will be more reactive than the other. So of course it will replace its position. You get the idea?
Mr. I can't understand.
Yeah, that's me. For example, here, once I told you, okay, so if let's take an example here, look with me carefully. If I just say to you that reaction, for example, let's take an example, AgNO3, that's gonna react with, for example, KBr. Okay. Okay.
Okay.
So in that case, let's see what would happen. So this reaction will work or not work. So you're gonna, I'm gonna back to the chemical activity series. Yes.
Yes.
What does K represent?
What KBr? Potassium bromide.
Oh,
okay.
Okay. KB one.
No, K is an
KB
element. That's
one-
potassium. That's an element.
like-
K is an element, while PR is another element. Okay, that's potassium. K, while PR is bromide. Okay.
Okay.
Okay. So here like this, AgNO3 plus KPR, as we can observe here. So we are gonna ask this reaction will work or not. So you said I'm gonna back to the chemical activity series. So I'm gonna ask you, let's check together, guys. Where is the positive part in that compound?
Ag.
Ag, that's the positive part. Good. Where is the positive part in that compound?
K.
K. So are they the same element?
No.
They are different, yes?
Who is
Yes.
more reactive?
So do you think that they are gonna have the same reactivity?
No.
No two elements have the same.
Probably.
No two elements have the same reactivity. So of course they have different reactivity, yes?
Yes.
So in that case, one of them is must more reactive than the other. I don't care which one, we're gonna just switch. Because once they replace this, the other one will take the PR. You get the idea?
Yes.
So in that case, it's not a must to know, but in single replacement, because we have a single metal or a single non-metal, single element, this element could kick one out. The other one will not find another substance to combine with. So in that case, I must determine this one is strong enough to kick this out or not. But here, of course, one of this, the potassium or silver, one of them must be more reactive than the other. So they are gonna simply switch places. So it will be KNO3 and silver, okay, will just combine with bromine and from AgPr, okay? You got the idea, guys?
Yes.
Yeah. So in double replacement, we are gonna find that the chemical equation follows that following manner. We have two chemical compounds. They combine together, or they react together and switch places to produce two new chemical compounds. Is it clear here like this?
Yes.
Is it clear
Yes.
like that? Okay, so like that, or we are gonna stop at this point. So we know how we could differentiate between synthesis, decomposition, single replacement, and double replacement reaction. Okay, so there are 4 types of chemical reaction we studied till now. Yes, Fadia?
دلوقتي you said
I can't hear you.
يعني
Just
AG and KI
Hmm.
method AG and KI يعني it doesn't matter which one is the more
Potassium
يعني
actually is more reactive than silver. But if you don't know, if even
so how we will,
again Fadia.
but you said it doesn't matter يعني we should
Yep, here it doesn't matter.
you
Why?
said
I'm gonna tell you, Fadi, because here Ag and K, I have two different metals. Of course, they have different reactivity. So whatever, if I don't know that K is more reactive than Ag, so what would happen? They would gonna switch. Imagine that. Imagine. Of course, it's not true. Imagine that silver is more reactive than potassium. What will happen? Silver will kick the potassium and take its position, so it will make AgBr, and the potassium will combine with nitrate to form KNO3. So it will be the same result. You get idea?
yes.
Yeah. Okay.
Yes.
So here, whatever the one who's reactive more than the other, it will replace its position. So the other one will take the first one position. You get the idea?
Yes, Mister.
Yes. Okay, guys. So we're gonna start at this point, as we said. Please study this part carefully for your textbook and check your SMS for the new uploaded sheets, okay, and the chemical activity series sheet, okay. So you're supposed to answer the worksheet that's uploaded, okay. So in her question
The
to
only
what?
worksheet that is uploaded to the smart school is the chemical equation one.
No, you're gonna. This one is uploaded today, okay. So you just check it, okay.
Okay.
So see you next week, inshallah. Please study this part very carefully. Check, okay.
مستر
Yep.
مستر في الكيميكال ايكويشن نفسها مثلا NaCl
Hmm.
plus HgNO3
Hmm.
يعني ممكن يا مستر هو لازم نكتب NaCl ولا ممكن نكتب مثلا ClNa؟
No, never. We will always start by the positive part. Actually, guys, after we finish that lesson, I'm gonna practice you how we're writing the chemical formula to be able to write and know the chemical equation. Okay.
Okay.
So
So
here,
you'll not take the composition replacement or reaction.
what?
You'll not take the composition reaction.
Combustion.
Combustion.
We didn't finish our lesson yet.
Okay.
Okay. So we just studied 4 types. We still have the 5th one, combustion. We're gonna talk about it next time. Just make kind of wrap up for the 4 types of the chemical reaction. Then we study combustion. Okay. Okay, guys.
Yes,
Okay,
Mister.
so please study this part very well. If you have any question, I'm waiting for your questions next session. Thank you, guys, and goodbye.